All right, on number 10, the first thing we have to think about is what it looks like. So it is an equilateral base and it's a prism. So it's going to look something like this. And what they're telling us is that all edge lengths are x. So this is x, x, and x. Everything's an x. All right, so we know to find the volume, it's area of the base times the height. Our base in this case is an equilateral triangle. All right, so that's going to be 1/2 base times height. Right, so the area of the triangle is 1/2 base times height. So we have 1/2. The base, which is here, is going to be x. And I need to find this height, right? I need this height right here. So let's think about that triangle base. A triangle base looks something like that, right? And we know all these measurements are x. So if I draw in that altitude, that height, if the hypotenuse is x, remember, because it's equilateral, we've now created a 30, 60, 90 triangle. So the short leg is going to be x over 2. The long leg, or the altitude here, is going to be x radical 3 over 2. So the 1/2 base times height is going to be 1/2 times x radical 3 over 2. Then we need the height of the prism. So this is our height of the prism, which is another x. All right, so we just need to simplify that. So if I look at what's all in the numerators, I have a 1, I have an x radical 3, and another x. So that would be x cubed radical 3. In my denominator, I have a 2 and a 2, so 2 times 2 gives me 4. So this is the volume of that prism. On number 11, you have a case that's tightly packed with 6 cans. All right, so we have this box here. Let's see if I can do a decent drawing here. All right, so we have this box and we have 6 cans that are packed tightly in here. All right, so use your imagination a little bit. Here we go. 6 cans that are in there. I want to know the ratio of the volume of the box to the volume of the 10 cans. So the problem is we don't really have any measurements. So we're going to try to find some measurements in terms of the radius. So in terms of r. So we know this is a radius. So think about how many radii go left to right. So this circle has 2 radii. There's 2 more radii. And here's 2 more radii. So this is 6 radii wide. Okay, now let's think about going this direction. There's going to be 1, 2, 3, 4. So this dimension would be 4 radii. The height, we don't really know. All right, so I'm just going to call that h for now. So let's start thinking about the volume of what we have. So we're looking at the volume of the box to the volume of the cans. All right, so my box, it's a rectangular prism. So length times width times height, area of the base times the height. So in our case here, we're going to have 4r times 6r times the height. My cans, they're cylinders. So that's pi r squared times the height. So we have pi times my radius squared, which we don't know the radius, so we're just going to leave it as r squared. The height of those cylinders, because they're in the box, it has the exact same height. Now the catch here is we have 6 cylinders. So I really need to put a 6 right here. All right, so I'm just going to multiply some things together, simplify a little bit, and then what we can do is start reducing our ratio. So on the left-hand side, I have 24r squared h to 6 pi r squared h. Okay, so let's start thinking about things that will divide out. So I could divide h on both sides. That would become a unit of 1. I could divide an r squared on each side. So I'd be left with 24 to 6 pi. So now I can divide both sides by 6, and I end up with 4 to pi. So the ratio of the volume of the box to the volume of the cans is 4 to pi.